And I asked you guys to draw the original as well as the second order derivative. So again, I've got to ask myself, those places are where g accent of x is 0. So if I look at the original, so the stars is where g accent x is 0. So this would give me the stationary points of G. So if I had to draw this on here, I know that G would turn or be stationary there. Okay? So now I look at increasing and decreasing. All of the parts above, my y values are positive, which means g accent x is positive, which means g of x is increasing. So here, g increases. And all of these parts below, my y is negative, but y represents g accent of x, which means g is decreasing. So here and there, g is decreasing. So I know my graph is going down. And here, my graph again is increasing. So there I already have a very good idea of my original graph. But now I did specify that gx must have 2 roots. Okay? So if I look at g, it means it's only allowed to cut the x-axis twice. Now please guys, now you can go mad. Okay? Now you can draw it like in 200 different ways. Not really, but okay. You can draw it in quite a few different ways. Like this girl, this lady down here, what's your name? Kaylee. What Kaylee did was she said, okay, it needs to cut there, turn, 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 and cut there. So it cuts only your x-axis twice. Let's rather do that. Okay? Or, what's your name, but? Seth. What Seth did was he said, okay, it needs to maybe turn on the x-axis. So what he did was he drew a graph that looked like that. Okay, whoops. Turn, turn, and go down. So it has 2 x-intercepts. So that in the exam is where we would give marks. We give marks, number 1, for your turning points. We give marks for your x-intercepts. But also we give marks then for your form of the graph. In other words, does it at least look like a cubic graph? Okay? Or a quartic. This is actually a quartic graph. Now you might go, but I don't know that. Don't worry, until this year I also didn't know it. So you don't have to know the name of the graph, but it must not have like straight, and then have, what do you call it, breaking points where it goes like this. It must still flow nicely. But now what about the second order derivative? Okay? I did say that the second order derivative, this turning point is nice and symmetrical around there, and nice and symmetrical there. Which means this is at about 3.5, and this is at 1/2, because it's equal distances between. So if I have to go and draw my second order derivative, it's going to be a parabola, because this is a cubic graph, have x-intercepts at 1/2 and at 3.5. Okay? But now the issue we are sitting with is it going to be smiling or is it going to be sad? Okay, now this becomes a bit interesting. Okay? How do you guys suggest we attempt this? Look at increase and decreasing of which function? The blue one, right? Okay. I like what he's saying. What he's saying is, if I look at deriving G accent, I get G double accent, which is the rate of change of this graph. Now here, here my graph is decreasing. So G double accent is smaller than 0 all the way up to here. My blue graph is decreasing. So G accent x is G double accent x is smaller than 0. But from here to there, my G double accent x graph is increasing. So it's positive. Then again from here, my G accent graph is decreasing, so it's going to be below. But what is going to be this point here? That's going to be the point 2, which is the turning point of this graph, which is going to be a point of inflection for this big graph, for the green graph. Okay? Now, ladies and gents, I want to put it out there for you guys. This is going to take some practice for you. Yes. And my humble opinion is the following. This is a level 4 type question. This one. Level 3, level 4, higher order thinking question, which maybe counts 3 marks. Now let me give you a tip. Practice it, but don't break your head about it. Okay? Make sure the other questions you can get 100% right.